Oh, this is space. I'm in space.
What's going on, everybody? It is another fine day in glorious Yakograd. Yakograd, the cool city. Apparently Yakograd means cool city in Bulgarian. Didn't mean to do that. Interestingly enough. Didn't mean to do that, but you know, hey, whatever. Whatever. Boff, puke, whatever. Alright, so we can shut the Starbase Live sounds off there. And yeah, let's jump in. Today we're going to be working on utilities. I'm going to probably have to go into the test save to figure out really how this stuff works before we implement anything. We started building it out last night, and I was not really what's the right way to say it? I don't really understand fully how the electricity works in the game. Like, I get it, but I wanna be absolutely sure. So let's let's just be absolutely sure. So let's go into the test save today and start playing around. Live stream of the SS United States being moved. Yeah, I don't want to look at that. Electrical. Yep. Probably magnets or something. Cold or cold? Hey, HBSX, how are you? Thank you for all the subs tipped yesterday. And RC, thank you for the tenor. I appreciate it, guys. Thank you. You know, you guys are just helping keep this, you know, virtual space station from leaking and crashing and re-entering. You're just, you know, keeping this space station on orbit, you know? Appreciate it. Hey, Kelly, what's going on? What's going on, YouTube chat? How you guys doing over there in YouTube land? Dude, how about that dual rocket launch stream yesterday? I went back and looked at my commentary, and I'm just like, it's so bad. I'm like, and that's happening. It was fun, though. We had some fun. It was pretty good. But, yeah. Oh, all right. So we're in the test save. And what we really need to... The test save is just a blank slate for testing things out. What I need to do is... You need to select energy management buildings. I'm starting a new game for this feature to be available. Oh. I gotta go watch that. I was on a call at the time and had you on mute. Chat was saying it looked like a tennis match because I was like, SpaceX, Rocket Lab, SpaceX, Rocket Lab, YouTube chat, Twitch chat, YouTube chat, SpaceX, Rocket. I'm like, yeah, it was pretty funny. All right, so I guess we can't test that in here, so. Click the menu. Like, dude, they launched within like a couple minutes of each other. So there were times in the timeline where I was trying to explain Falcon 9 and trying to explain Electron, and I got like super worried that, you know, I tried to, and on top of that, like making sure I had the right rocket up on the right screen. It was a little bit of a game. Yeah. And the squirrel got into the office. Squirrel! Squirrel! Raiden, how you doing? Curious about the sanitary gravity pipes, how the pipes work in game. Or what's the plan for that if everything is flat? Well, Mike, you can set the depth of the pipe relative to height. I made everything flat, right? Because just to be absolutely sure, like the city where all the plumbing is going, where a lot of the plumbing is going to be, and where all my buildings are, is at 40 feet above sea level. That's on purpose. All I have to do is basically set my drainage at sea level, and then we can run the pipes from there. You could set depths on the pipes, so you could set the pipes 10 feet, 20 feet, 30 feet, right? And I'm thinking, like, have the drainage at 20 feet, right? What I want to do with utilities is have electrical. Obviously, you have above ground electrical, right? And then 10 feet below ground, you have, like, low voltage electrical. And then below 20 feet, you have, like, plumbing. Or, like, maybe 10... I don't know. What would be better? I can't really tell. Basically have, like, 10 feet for electrical, 20 feet for plumbing, you know, 30 feet for, like, a tunnel or something, like a subway or whatever, you know? So the test logic save isn't going to work, so we need a new custom game. The New Republic is born. Start in 1980. Energy management. You will build power lines, vehicles will use fuel. You build power lines, vehicles don't. Yeah, okay. Well, we could just do that for this. Unlimited cash. If we're gonna do water management and waste management, I don't need maintenance. In the test save, we'll disable that. All right, 1980 should give us everything that we need. So let's make a new test save. Some subway stations in Montreal, you go through 2 to 3 flights of long escalators to reach the subway level. Yeah, there are some subways that are like just below the street, and there are some subways that are really, really far down. I've ridden on the metro in Montreal before, all systems. Yeah, it's yeah, those are deep. I remember coming out of the metro to get on the island to get to the Formula 1 race. I forget the name of the island that the Circuit de Villeneuve is on. I forget. Yeah, it was like a long way up. I know that Moscow's metro is 50 meters. 50 meters below the ground in some spots. That's 150 feet below the ground, which is crazy. Yeah, that's the yellow line. Yeah. All right, so let's figure out power. I'm not sure how exactly we're gonna do this, but once again, this is the test save where, you know, you could just, it's kind of like a sandbox. You could just build it. Like, see, it's building the road for me. This plays a little bit more like cities. So what we're gonna do is I'm just gonna prototype out and diagram designs here for how I want this set up. So what we decided last night was that we want the NATO electrical connection and the Warsaw Pact electrical connection to connect into each other, and then connect that into kind of quote unquote my main wire harness that goes across the entire map, so to speak. So I think I got a good idea and a good handle on how the electrical works, but I'm not like 100%. I'm not 100% sure, so I'm just gonna start tampering with this stuff. There's a couple of things that I want to check. I want to check if, basically, I want to see if there's electrical resistance. That's a big one. I want to make sure that, you know, make sure I understand if there is like power, like electrical power, that we understand how it works. Like transmitting over distances, etc., etc. Think about how we checked like grades with roads and stuff, and we tested train logic and stuff. So let's connect that up over there. Connect that up over there. Okay, so we have our 2 power lines coming in, right? Obviously, if we switch the import, right, we're gonna get 18. Okay, so we're operating, these are 109,000 kilovolts, or 109 kilovolts, 109,000 volts at 18 megawatts. So you have your voltage and then you have your draw, right? That's the draw. So if this thing goes over here, you're going to have a problem. To activate snap, double tap F1. Yep. I'm new to this game. How do you use the grip and snap while building? Okay, so there's a Cascadian. So check this out. There's a couple of different things. You use F1. Use F1, F2, F3, and F4. All right. So F1, it brings up the grid. When you're building, if you tap F1 again, you have grid mode with grid snap, and you can build on the grid. I use that to keep things nice and straight. That's how all my stuff gets built, and it's really nice and clean. I forget what F2 does. I don't use that very often. So F3 is your underground view, and then F4 is a tool that allows you to snap parallel. So F4 you can use to make parallel roads. See? Super useful if you're trying to make a multi-lane road. F4 will snap to the road. Now, keep in mind, you can snap to grid and you can snap to road at the same time, but sometimes they don't play nice when they're near each other. See what I mean? Like, sometimes one overrides the other when you're close. So you got to be careful about making sure you know what tools are on. You can see what tools are on over here. Oh yeah, F2 is the topography. Excuse me, I'm stupid. Sorry, muscle memory. Yeah, F2 brings up your topographical map, so it shows you heights. And then you can see what heights they are if you go into terrain tools right here and go to one of my favorite tools in the game, the tool for measurement. If you just hold it over, you can see the height above sea level. It only shows height above sea level. It doesn't show depth here. But if you take the tool for measurement and drag it across, you can get what's called a profile curve here, and you can see the height there. That stuff's super useful for making roads nice and smooth. Okay, so this has power. Now we need something that's going to draw power. This game looks like what you play when Factorio gets too easy. I don't know if this game is easier than Factorio, but it's definitely complicated. So I'm just prototyping the design here for the most part. There we go. So I like putting my utility buildings inside of a fence and stuff. I like using the Mauer wall. Prefab fence is cool too. Those are all very Soviet stuff. I like using this because you definitely don't want people near this. But there are a bunch of different types of walls that you can... May want to include a step-down transformer near the switch. Yeah. Yeah, this is like Factorio's and City Skylines and Transport Fever all rolled into one. Yeah, probably, Andrew. That's probably for the better. Alright, hold on. So, where is the transformer? There it is. It might be better to put like the transformer over here, Andrew, and then have an underground line connect to it. Like, you know, I want to use this to see how electrical works, and I also kind of want to get into some, you know, design here. But this is more, you know, now that I'm thinking about it, this is more about, like, how this all works rather than design. Design we can do in the main save. I just need to see this. I need to see this stuff in action. Oh man, if only it was that easy. You need to put the smart hat on. So, I'm trying to figure out how we're gonna test this. Like, we need something that draws power. But I need something that draws power kind of passively without people in it, you know? What do you want to test? I'm looking to test distance of power lines violent, if that does anything. To how the power, like how often... Okay, so let me put it to you like this. Let's do this, right? And let's say... every certain amount of distance we put a switch, right? Right? I'm putting it every 2,651 feet, because that's a half mile. That should be good enough. We definitely want to always be switching, but I need to really see, like, if we're getting some voltage breakdown here over distance. I just want to be absolutely sure. I want to test it. So we drew some power. The game is, quote-unquote, filling up the power line. That's why we had a draw there for a second. Underground lower voltage. Yeah, it is. The underground lines can only go to 12 megawatts, the underground high voltage. So, from a design standpoint, we're obviously going to need... we're obviously going to need different types of substations. We need a high voltage transformer substation and then a, you know, low voltage transformer substation design. So say we went over here with it like this, right? And then we built a transformer right here, right? And then, you know, obviously we connected it. Let this be kind of a high voltage one, I don't know. Right? Now, just... I'm just trying to build something, you know, quick-ish. What the hell? Why did it do that? Oh. Okay, so also I'm using this to kind of figure out some building mechanics, I suppose. Doesn't look like they like being next to each other.
Discovery, go at
Like, let's
throttle.
go all the way down here. Right, and then connect the substation in. Right. Hey, Kyron, 79-month resub. Why does it say unlimited? Did you turn on cheats? This is the test save? Now, if I'm understanding this right, 2.5, we could take 2.5 megawatts because, wait. We have 2.5 megawatts at our disposal. Now, if I take this, right? We connect that back in. What happens now? All right. Now, what I want to see is that small water well. Max power consumption is 5.1 megawatt hours per day. It doesn't say how much voltage these things pull. That's really what I'm looking at. Seems like only one wire can supply it at a time. Right, so that's pulling 0.035. And it's showing basically that. 230 volts. So all this stuff is on a 230 volt system, which is kind of par for the course for Europe, as we figured out yesterday, right? So I just want to fill all these things up. All right. So now what does this say? Oh, yeah. We gotta have that water pump. Forgot about that. I put pumps down because I just want a passive system, but I guess we don't really particularly need the water towers. And the wall came down, all the way down. So everything's wired on a 220 volt system, at least the water pumps are. Now I'm wondering, would like an industrial building be on the same thing? Once again, I'm just using this to test. You're drinking the wrong water. Gatorade, H2O. There we go. That's what I'm trying to see. Okay, so if we go into low voltage lines, we get rid of that, and I add the same substation over here, right next to it. It'll split it. Okay, cool. All right, we know that that works. Water, you mean like in the toilet? Sure. Now, what does that say for back here? We're pulling 1.5 megawatts here. Okay, so now we take our clone thing. And let's just put that over here somewhere. Once again, I put down mass water pumps because they consume power and there's no personnel required to run them. I'm just checking to see how power works. You see those new KSA screenshots? I did. Okay. I mean, this isn't anything that I didn't know. I'm really more interested to see how many times you can split this. So, like, can we go over here? Right, like, say we go this way, right? Add another switch. Put a transformer down. Right? And then give me my water pump arrays. Like, this is just going to take a second to set this up, but... Now, what that's going to do is put way more draw on this thing. Okay. Cool. Split it again. Split it again. Split it again. Split it again. Put down the transformer, right? And then clone my water pumping arrays. So once again, this is designed to stress test this. I'm just trying to simulate a power harness that we'd have for like a city or whatever. All right, so now back over here. Okay, we're almost maxing it out. Now, I'm wondering, downstream from this, what's the draw? Nothing. All right, let's overload this. Like, I'm kind of trying to figure out at what point are you going to need a second line. So, because we're obviously going to need provisions to build out, you know, power lines once we hit a certain capacity, right? Like if you start exceeding the draw on the wires, obviously you're going to have a rolling blackout, right? You don't want that. I think that will be worth adding to the rotation when it comes out. I don't know. We'll see, man. Okay, so you can get pretty hardcore with this. You can see the power draw in the overlay. Really? See? Look. That's what I'm talking about. It split it. So we're at 109,000. We split, and that's 88,000. See? See, you can see that this is putting stress on the system. This is exactly what I was looking for. Thank you. See, yeah, every time you split it, the signal gets weaker and weaker. See, out here, we only have 5.2 megawatt draw, right? But this one is 109. And that one's 109. That one's 109 to 109. Yep. Frickin' water storage is built up. So, okay. Here's the thing. This is what I wanted to figure out. I really wanted to understand the logic of how this is all working. Right? So, it's very clear that we need a main power line. A big main power line. Not something that's split very often, right? Any plans on covering this? The SST Space and Aeronautics Subcommittee hearing step by step the Artemis program and NASA's path to human exploration of the moon. Wednesday, February 26th. From the House Science Committee. Yeah, we can cover that. Sure. Yeah, pumps aren't running, so the demand is dropped. I wish we could get something that has constant flow. Heat would be constant. Yeah, but heat needs people to run. Actually, oil pumps have probably been good, but we can only pump that in certain areas. I need a more passive thing. Anyway, I'm just trying to figure this thing out. So when there was a power draw, we had a voltage drop, right? Voltage drop and a wattage. The wattage went up and that dropped the voltage, right? So you can only split so many times. I'm trying to just figure out more or less kind of building codes for how we should set up the wire harness. Because, like, all right, let's do something interesting here. We need something that passively generates power. Oh, we have to research the damn SPP. I'm having trouble getting used to it, JDG. You can't discharge water. What I can do is just empty all the storages. So, I guess basically what I'm trying to figure out is the logic required for when you would really want to split. And then how many times you can actually split before you really have a problem. In this particular case, with basically max drawing these things, we split this line 1, 2, 3, 4, 5 times. And then it was having some draw problems. See, we're not exceeding anything, so we don't see any voltage drops. Water fountains draw water and power. If you press CHE in one go, CHE will give you cheat options. CHE. In one go. What do you mean in one go? So CHE. I don't understand. Oh. Do we have a cheat menu to get to? Oh.
Oh, this is space. I'm in space.
Thank you. Does the solar power plant need people? Yeah, it does. How much is that big wind turbine? 35 megawatt hours. So for instance, if I wanted to do a wind farm, right? Now, like once again, I just kind of want to see, the grid has to, okay, guys, am I thinking about this right? Here, let me just go into paint real quick. So the grid needs a source, right? Right? And then you have like a main power line that goes out of your source, right? And then it seems to split, you know, like this. Like branches like a tree, basically, right? and each one of the branches is a transformer, right? Am I thinking about this correctly? Okay, so here's my question. What if over here we have a power plant? Right? Could I just plug... What happens if I plug a power plant in right here? Isn't that technically backfeeding the grid? There are transformers. Dead scum, yeah. Power plants are equipped with step-up transformers into their design. And then there's step-down transformers that you have to place. So... And for the most up, step up and step down to the same. Just run it in reverse. Note, I'm not a power expert. You can do that, I believe. But here's the thing, Mill. If we're feeding over here, so, right, let's just say we have our... I'm not writing PP right there. Say we feed a nuclear power plant into here. Obviously, we're not feeding it into a low voltage line. If I'm looking at this right, and this is really what I wanted to figure out. If I'm looking at this correctly, so say we have a junction here, right? A junction there, a junction there, a junction there, and a junction here, right? And say on the ends, we have our transformers, okay? All right, circles are transformers, squares are junctions. Right? Say we feed the NPP over here. Now, our original source power, right? Say we go to this area right here. Let's pick out that one. So now, how many switches removed from that? 1, 2. You're 2 switches away from the source. If I plug my NPP in over here, right? If we do that, now this same thing is 1, 2, 3, 4, 5. It's 5 switches away from source. See what I'm talking about? That's no good. This is what... I had this problem when I played a lot of early saves. You can only switch power so much. Okay? You can only switch it so much. Right? So, right? So let's say here, we take the MPP, right? And we saw that the further you get away, right, the wattage goes down, right? So ideally, you want to keep, you want to make it so you have the least amount of switches between where your power is and where your sources are, right? So plugging the NPP in here makes it so now if we deleted the source, right, instead of it being 5 junctions away, it's 1, 2, 3. See what I'm saying? This is what I mean about us needing a main power line. You need a main line. That's really, really important. I've been testing cable distance, Mowgli. It doesn't seem to be that big of a deal, from what I can tell. I haven't tested it beyond like a couple miles, though. But that's where my next train of thought is going, right? So ideally, what an ideal grid would look like, right? Say we have our nuclear power plant, right? You would want... Right? You go out here, you switch, right? Obviously, keep going, right? You don't really want to ever get 4 degrees of separation away from your NPP, or for any power plant, right? Like, you got to think of it like degrees of separation, right? So now here you have a transformer, there you have a transformer, and there you have a transformer, right? You could plug 3 transformers in off of a bigger switch. And then over here you have a transformer, over there you have a transformer, over there you have a transformer, right? And then you could probably end up doing it. I actually wouldn't do it more than that, right? Because that stays 3 degrees of separation. But say, you know, we have our city, right? Say all this is city number 1. Say over here, we had city 2, right? How would we do this? You wouldn't want to, like, switch this and then just do that. That's bad. That's not going to work, right? So what you'd have to do, or what I'm thinking, and this is why the next thing I want to test is distance, right? There's 1 switch junction, right? Over, right? 2 switch junction, down, 3. And then, no, that's not how you would want to do this. You would want to go out this way, right? And then angle that wire in there. I mean, just for the diagram's sake, right? You'd want to do this. Right? This is how you'd want to get this. Like, if there's any electrical engineers out there, this is not necessarily wiring in parallel, right? It's not in parallel, but I would call that parallel lines, right? Like physically parallel lines, right? And then say we had an industrial complex over here, right? Something like a steel mill that needed a lot of power, right? What you'd want is that line to go directly to it and then switch to the transformers like that, right? You basically don't want to say, you don't want to go too far away in degrees of separation from your power plants. Now let's just get rid of our industry thing for a second. Let's just say, we follow this plan, right? Say we're following this plan. Now, here's where this gets a little weird. Say we have an oil power plant over here, right? Say, I don't know. Maybe oil's cheap. Maybe we want to do it. How do we fit that into this system? How do we do it and still maintain our 3 degrees of separation? Technically, the easiest way would be to do this, right? That adds. I'm not an electrical engineer yet. You want a high voltage power grid with the transformer stations in the cities and substations going off the transformers. No, I understand that, Shy. In this, a circle is a transformer. This is a switch. Right? Sorry, that writing with the mouse is weird. Just pretend that says transformer, okay? Okay, so this is all fine and dandy, right? But now, in this design, say we need an industrial site over here. Now what do we do? You get the high power priority switch, feed it both borders and your own power, and build the net after that. That's what I'm getting at, dude. That's what I mean. So this is all fine and dandy. This will work, but the better way to do all this, right, is to have a singular high voltage line. Like, we need a power feed that feeds these grids. You could run another main from the MPP. Sure, of course. But what if we did this? Let's just say we have border power, okay? Just BP is border power. What if we did this? Right? And then we did one line out, and say you could switch up to 6 times with the big switches. Right? The voltage has to higher than costumes. Costumes power will draw down to a lower when used. It has 3 in and 3 out. Yeah. So this should feed right from what we just tested. Simply, you have to do math. The buildings will tell you how much power they need. That's... Violent, no. Not in this. This is assuming that everything is drawing maximum amounts of power, based off of what I just saw. This is assuming full power. Assuming, like, maximum power draw. Right? See, I'm not sure what that is going to do in this design. What having that extra switch there is going to do. Even though that extra switch is generating insane amounts of power. At this point, if the oil power plant, remember, our lines can only take, the maximum would be 18. These can only carry 15. So, oh. Now, I added my prototype switching station here, right? And it says there's a maximum of 19, right? Do your buildings in game drop voltage? Yes, Jonathan, they do. I already said that. What happens if we set this to 18 and we import power twice? What does this do? Yeah, it maxes it, but it's not going to go any further than there. Hey, Flip. You want a main line to the industry that has its own transformer at the site. Well, yeah, of course. Sun Temple, you just linked the electrical grid wiki page. Okay. I don't... Yeah, Violent. Now we have to draw a new line. Exactly. So we're feeding the oil power plant. You're feeding oil, the border checkpoints, and a nuclear power plant, right? You're going to need multiple lines. Now, what do these multiple lines look like? Is there a way that we can feed all of these lines? So, like, can we feed everything into one switch? Like, what's the maximum that these switches can take? Okay. I gotta test something. Get rid of this. Now, what happens if we... What happens if we do this? We added another line. Now what does it do? It's still reading 19 total. Well, you're saying it adds capacity, but we're not seeing a max wattage here. I doubled up. Basically, what I'm trying to tell you is I doubled up the lines and it's not working. Dean, I'm gonna let that message go, but I don't want to talk about that stuff, homie, okay? I don't think you're importing energy from NATO. So in the drawing you have, in my first game I added wind power to the main grid, and the lights went on, off, on, off. This is ghost power. Also, the max power of a switch is 18 or 19 max. $19 megawatt. I wanted to see if putting in 36 megawatts of power into this switch is changing anything, and it's not. Okay, so your switches are limited to 19 megawatts. You can't go any further than that. So at some point, you just have to double up the lines. Like what I was seeing is if you could combine them, but you can't. So you want industry before others. Yes, Sun Temple, I get this. I understand this. Yeah, Dead Scum, that's what I'm getting at. See, this is no good. This is not going to work how we want. See, this is what I'm wondering, and this is really what I'm trying to understand. Me, it's not any particular problem, it's just me just not really, A, getting electrical engineering too hard, like understanding it too much, right? But, but how the logic works in the game. Scroll down a bit. Nice. Yeah, those are 500 kilovolt three-phase electric. 500. Damn, dude. Apparently, come April 19th, Twitch is setting a 100-hour limit for highlights and uploads. Why is all this white stuff coming out of the sky? What is it? I don't know. Yeah, you want to hook up more than 19, you need a second line. One loop for every district. See, the interesting thing is, I'm looking at this, and this is like kind of connecting everything together, right? Like, I guess I'm just trying to figure out in game what constitutes like adding another line. And if you add another line, how does that work? Right? It seems like, you know, in my other diagram, right, I had a power source here and then a power source there, and they need to kind of stay on their own thing, right? So you need to know how much power every district is pulling, up to 19 megawatts, and then add a new power plant for additional power. Yeah, technophobic. Yeah, I got you, man. Yeah, I know I know like the draw. Like I get that. I would say it's probably a good thing. It would probably be a good thing to, how are we going to be able to get the full power draw of everything, though? Rocket Guy, I'm trying, for whatever reason, electrical engineering isn't clicking in my brain, nor is how it's working in the game really registering me. What's the question? Okay. Let me just look. Let me check something, okay? Let's look in the game. A nuclear power plant. Can produce 4,680 megawatt hours a day. Now, Hokie, okay, this is EJ idiot question time. Okay, so 4,600 megawatt hours a day, and I'm probably not, this is probably an obvious one, but I'm just going to ask it anyway for continuity here so I can get this right. So the MPP produces 4,680 megawatts a day. The lines can only take 19 megawatts. What is the correlation here? We can make 4,600 megawatt hours of power, but we can only throw 19 down a line. What's the correlation? Like, I guess what I'm asking is for a 4,600, if we're producing 4.68 gigawatts of power, gigawatt hours of power, how many lines am I going to need here? Like, how many lines would I need to send all of that power down all of the lines? The NPPs have multiple outs. I understand that, Adzio. I get that. I know. But see, the nuclear power plant has 7. 7 out, right? But... oh, wait. No, it looks like it has some on the other side. No, it doesn't. A megawatt hour equals 1,000 kilowatts of electricity generated per hour and is used to measure electrical output. At 4,600 megawatts a day, you're producing about 191.6 megawatt hour, assuming 100% production. So, okay, survey slave. So if we're producing 191 megawatt hours, right? And the lines can only move 19 megawatts maximum, right? So 191.66 divided by 19 a line gives me 10.
Discovery, go at throttle up.
So, see, that's what I'm wondering. Like, with the single nuke, yeah. This is why I stopped playing this game. Too much math involved. Oh, Aki, that's what makes this fun. See last two. Power substation can support about 2.5 steel mills. A nuclear power plant has 8 big power output lines. I saw a video. Someone had 8 vehicle and 2 train factories and 20,000 on an 18 megawatt line. Maximum production per workday, 4680 megawatts of power. Megawatt hours of power. See, this is where this is messing with me. Now, see, this reads 19 on the max gauge there, so let me just check something. 191.7 divided by 20, 9.5. And the NPP only has 7 high voltage out. Yeah, Aki, exactly. It says maximum production per workday, 4680 megawatt hours of power per workday. That's what it's saying. How many watts can a single line take? 19 megawatts in a single line. It's a workday 24 hours. I know that a worker will only work a shift at a place for 8, if that helps. I'm going to go ahead and guess that a workday is 8 hours. So that would be 4,680 megawatt hours of power every 8 hours, right? Assuming a 24-hour workday, 4,680 megawatts divided by 24 hours is 195 watts. That can saturate roughly 10 lines at 19 watts each with 5 left over. That is true. Absolute 100% is effectively impossible in this game. I understand that, little P. But I have to figure out a safety factor here. If we shoot for a grid system that's designed for 100% production, right, which will theoretically never hit, we're theoretically never going to have to worry about wrecking our power grid or having to change anything, right? Do you have a way to test? Is there a power sync you can use using cheats? That's what I wanted to test with all these things, but 19 megawatt is the throughput like your lines are capable of. That means your total megawatt hour per day is 19 times 24. 456 megawatt hours is your maximal throughput per day on each line. So, if 456 is the maximum, right? We take 4680 and divide it by 456. Yeah, 10 lines. The nuclear power plant can saturate 10 lines. But the nuclear power plant only has 7 high voltage outputs. And we have 6 small ones. The 6 small ones gotta be the extra, dudes. That has to be the extra. Hold on. Let me look at the transformer here. Yeah. Yeah. That's the extra. That's our discrepancy. That's what I'm wondering. It's the small power outputs. That's the difference. We have 6 low voltage connections out. That's where the extra megawatts are going. Does the nuclear power plant consume electricity? Well, yeah, of course. Max power consumption a day is 7.8. Oh, I see what the developers did here. They designed this. They designed power output, and then they took away the consumption of the building, and whatever power they had left, they made into the connections. I get it. That makes sense. That makes way more sense. How much can a low voltage line take wattage-wise? 1.2 megawatts, right? And then substations. For whatever reason, the lines can only take 1.8 megawatts, but the substations can take 2.5 megawatts. I don't understand that. That doesn't make any sense to me. Two 3.5s is the biggest mid-voltage line. Yeah, that's right. I forgot about that one. Can 2 lines connect to one substation for low voltage? Yes. Yes, you could connect 2 into 1, and that would maximize. That maximizes your substation. Can you look at a transformer? Here, Hoki, I can bring up the, See, the transformer is showing 109.97 kilovolts, and this is 109.92. Why would this be lower than this? Not if you get to program what thermodynamics does, i.e. the game. Yeah, right. See, these aren't drawing very much. We're pulling 0.0004 megawatts. So what is that? Each one of these is pulling like... It's pulling next to nothing because honestly, we're not powering the pump. We're just powering the stupid light on the side. That's just keeping the lights on. If I empty this... Right? See, now we're pulling 0.035. Right? Wait, why is that one pulling? Oh, Mr. Krabs, I am so confused. Resistance? Well, generally you wouldn't get higher voltage from resistance downstream. Are they hooked up to a pipe network? No, they have internal storages though. The internal storages is what I'm using there. I don't understand why this building is pulling power though. Why is this one pulling? Why is that pulling 0.035 megawatts, even though it's doing nothing? And then these buildings over here are doing nothing. They're see? This is where I'm really getting confused. Why are these ones pulling and why are some pulling and some aren't? What's the logic here? Like, why are you pulling power here? I don't understand. That I don't get. Some of these are drawing power, but they're not. Some of them are drawing power like they're pumping, but they're not. Interestingly enough. You want me to hook it into a pipe? Sure. Did some wells like auto connect into each other? No, I don't think so. Hey, Carlos, I'm testing. I'm testing out stuff. I'm testing out how power grids work in the game. Now, okay. Real life question. So this is a visualization of a power grid. 380,000 volts, 220,000 volts. Green is representing transformers, right? So you have high voltage and lower voltage, right? So you see how some of these are in a loop for the most part? They're in loops. If we go to paint, right? Like, say we have a switch out of the oil power plant, we have a switch out of the border power, and then we have a switch out of the nuclear power, right? And then we connect them all together, right? And then we have, let's say we have a switch here, and then that one goes here over to there, right? Is that replicating that sufficiently? Yeah, probably, Raiden. I would chalk that one up to a float point. Is it the same buildings on every copy of the array? I don't know, Rothland. We'd have to look. I just want to... Do I look like I know what a JPEG is? I just want a picture of a gosh dang hot dog. Was there a limit to the switches? The switches can only take 19 megawatts. Right? They can only take so much. So the diagram sort of looked like a model railroad layout. Yeah. So yeah, why use them? What do you mean why use them? I don't understand what do you mean? Transformer dealing with one of throughput. No, that's not really what I'm trying to do. How much power can one of these make? 35 megawatt hours of power. Interesting. The 19 megawatt branches to 3 8 megawatt lines. Yeah, this is screwing with my head. See, it make me sneeze. It's turbo. Rothrin, it's not the same ones, for what it's worth. Bless you. Thanks, man. Alright, let's take a look here. So those wind turbines are doing their thing, right? What happens when I connect this? Hey, give me this back. What exactly are we trying to figure out? I'm trying to figure out what Workers likes for a power grid, like how it likes to be set up. That's the big one, dude. Long story short, it seems like look at this, consider this diagram, King Kitten. This, not this one. This doesn't seem to be the exact right way to do this, but, like, you could have a line going here, and then a line going here, and then a line going directly out to your industrial site. So, what I was basically looking at is that, assuming, like, everything is, all your transformers are pulling max power, here's what I did in Workers, right? So, I have 3 sets of water pumps, something that's basically maxing these things out, or at least pretty dang close to their max power consumption. And I have them coming off of a source here that's connected into border power, right? So the border power goes down here. The border power splits, right? It splits once here, twice there, 3 times, 4 times, 5 times. At 5 times, we were starting to have some real issues. Basically, 5 splits is kind of, and these, I stacked all these water pumps in here, to basically just draw a ton of power all at once, right? And basically, we started to see a real drop once I added like the 4th and 5th, particularly the 5th. It started to get really bad. Like, obviously, we lost power. I mean, they're not pulling right now, right? Because all the tanks are full. Like, if I shut the tanks off here. Actually, hold up. Let me do the test over again. I got an idea. My thought question is, why use a switch if one line of a power plant output can only be the same as a switch? Well, that's, think of Yama, that, and see, this is where it's getting, this is tough for me to explain. Think of the power lines as a pipe, right? Where, you know, it's a water pipe and it's a certain diameter. It can only handle a certain amount of water going through it at a certain, you know, flow rate, right? You have to add more pipes, right? And, you know, if you have water that's at high pressure and then you split it and you split it and you split it and you split it again, right? You can only split it so many times before overall you're seeing a huge pressure drop in the system, right? Electricity works the exact same way. It works exactly like that, but watts are your water pressure in this analogy, right? I'm trying to see where it's applicable to add another pipe and why. Okay. Somebody compiled an electrical guide for this game. If you'd like me to link it, it's verbose and informative. Is it Bibalio? Because that guy's awesome. Yeah, he's a great Workers resource of information. So, all right, here's what we're gonna do. I'm gonna make one switch. I'm gonna put one switch. No, Silent Shadow. Yeah, I don't know that guy. All right, put one switch here. Cheats! Cheats! Shut up! Cheats are fine! Shut the research off. Okay, good. All right, so here's what we're gonna do. Plug that sucker in. Actually, you know what? Don't plug that sucker in yet. Don't do that. Let's make the rest of the grid first. We'll use the biggest power lines that we can. We're going to do a test of the emergency broadcast system. Actually, just hold up. I don't need to make any of these high wires first. I'll show you why in a second. Let me just measure something. Okay, so a half mile down here. Let's build our transformer. Right? Build the transformer out, right? And then we'll connect we'll make our substations here. So out here. Oh, it's a guide. Sure. I want this for continuity so you guys can see it, but I'll keep the guide up. I have it now. Cool. So let's go back into workers, right? Now, put our substations out here, right? And then let me get those water pumps, or the water wells again, right? Okay, so we got all of our water pumps. I just want to make sure we can see our theoretical max consumption here. There, 102. All right, that actually is enough to blank out one substation, if I'm looking at this right. I always assume the power draw is balanced from every connection substation, so if you have an area drawing 30 kilowatts, you could add 2 substations and they would equal around 15 each. Is that not true? I think so, King Kitten, but I need to see it working in real time. Before I didn't. So what I'm going to do, all right? Actually dump that. Estimated total wattage of all connected buildings. Estimated maximum consumption, 1.28 of 250. Ah, there we go, it updated. Excellent. All right, so that's what we need, okay? So we have 6 connections, 6 low voltage connections. So take this thing, just bring it over here, and I'm just gonna make a copy of it over there, and then we're gonna mess with this, right? We need 1, 2, 3, 4, 5 to 5, and then 6. Okay. Now we're gonna use the maximum low voltage line, which is 235, right? Then connect all this stuff in. And let this in this experiment, this is basically going to represent like a city, right? There we go. Okay, cool. Or this is going to represent one transformer, so one part of the city. So now what we do, take this whole bad boy, right? And then we'll switch the power line again. Here. Ooh, the game didn't like that. Ah! I might have to add a, There we go. Alright. So. Now, we need to make this all work correctly. So, once again, get the biggest... We need the biggest lines that we can possibly handle because this is a max power test. So that's the biggest one, right? Those carry the most that the switches can take. Now we take this, plug that in over there. From here, we go to there, right? So we have 1, 2, 3. Four. Did I only put 4 down? I only put 4 down. Whatever, that's fine. This is still good enough. So we have our clusters here. In this analogy, that's representing basically that. It's one of those. So that's one of these. Okie dokie? So now what we're gonna do, go to our power import here. Also, I'm gonna save the game. Yakograd test, overwrite. So I'm gonna save it like this so we can repeat the test if needed. So what I wanna do is go here. City 1. Paste. Or pin that window. Go here. City 2. Right? Go here. You see where I'm going with this? These are in series now. One's right after the other. Oh gosh, this is like playing Kerbal. The medium line is 235. Yeah, I noticed that 235 doesn't go to these, but it's going to basically maximize the draw, as far as I can tell, right? Alright. So, now with all that being said, we go here, and we get an 18 megawatt line. We go here, we connect it. Now, we're not going to be hooked up to power just yet. What we got to do is go here and set the power import. Now, this is the first test. I want to see what the switches do, okay? I'm going to stagger these windows so it's just a little bit easier to look at this stuff. All right, ready? Pause. It splits your wattage. Yep. See what I'm talking about? Look at the first one. City 1 is maxed. That is maxed out. It's maximum power. City 2 is half of that. City 3 is half of that. City 4 is half of that. There you go. What I'm wondering here is why we are at 87 kilovolts. That's what I'm wondering. Why 87? What happens... Having each split will half your wattage. We know that. All right, we figured that one out. So let's reload the test. Hi, Yum Food. Come on, bury your head in here. I won't bite. Or whatever. Learn about electrical engineering and workers with me. Infrastructure. All right. All right, so the next test that I want to go and do here is... City 1. City 2. City 3. City 4. Now, the next one I want to do is pulling power from both. Because I noticed my kilovoltage was at 87 across the board. Before it was 109. We weren't maxing out the maximum voltage capacity for these lines. Voltage capacity? That's not the right way to say that, is it? All right. Okay. So, pause the game. Crank the import to maximum. Crank the import to maximum. Okay. Now what? Okay. Now, to be fair, I did not check the input switch last time. I didn't check it. But the input switch, where both of these connections are coming in, is at 109. Now, is it at 109 because we're bringing in double power, or is it at 109? Interesting. What the snozberries is going on here? So we're getting a voltage drop here because that switch is basically trying to let all the freedom out. Okay, got it. So you really never want to go maximum on these things. You'll get a voltage drop. Now, what happens if we... Uh-oh. Voltage does drop when you can't provide enough current. It's a physics things with batteries. Yeah, no, I get it. I understand that. What I'm trying to do is kind of prove that this works somewhat analogous to real life. And if it doesn't, figure out where it differs. It seems pretty straightforward to me. Yeah, Andrew, voltage will drop in real life. Yeah, exactly. So now, what happens if we beef this sucker back up? What happens if we crank that to maximum? So it'll pull more power from wherever you last told it to import from. Look, it's pulling 17. And then if you were importing 2 again, it'll double up. This will pick up. So like I set this to import first and then this to input second. Right? But look. That's so bizarre, dude. If I'm set to purchase 1.8 megawatts here, why is this thing pulling 17? That's strange, man. No, Chickenhead, I haven't seen it. Now, okay, here's my next question. So the City 1 switch, we're going from the input switch, which is, if you can see it around your screen, it's right there, right? The input switch goes to City 1, right here. Why is there a voltage drop here from 109 to 88? Why is that like that? What about a 6 connector high voltage switch? I'm not sure, James. In what criteria is the Did you hear that McAvoy will miss weeks of playing due to an infected shoulder? Can you loop it to equalize the watts where you need from your various power sources? That would be another thing to test, Michael. That's what I'm wondering. If, like, what does a loop look like? This is just straight series, right? Like, see, what I'm wondering here is this goes to 109 to 88, right? And it just stays at 88 kilovolts. But our wattage goes down every time. Yeah, and we're getting a rolling blackout here. Because it can't handle it. Yeah, Tessa, exactly. Oh, wow. Woof. All right. So, Michael, I'm gonna loop it. We'll see what happens. Disconnect City 4 for testing. Why? Maybe the voltage will go up. Yeah, okay. Huh. Look at how that split it up. That's weird, dude. But path of least resistance, right? So City 4... Well, theoretically, shouldn't City 1 and City 4 both be pulling the same amount? Now, the Ilios foreign power connection is here, and the Avriu connection is here. Now, what happens if we do this? Oh, 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 oh. Try a separate switch from NATO and one from a Soviet connection, NATO to City 4 and City 1 to Soviet. Why, Mowgli? So looping the connection made it a little angry. I think this, if I'm looking at this right, this is, so we're getting pretty good voltage across the board here. This is, we just don't have enough power to feed into the system. Do we have a power supply over here from Apatomo? We do. All right, hold up. All right, wait for it. Well, that doesn't make any sense. What the hell? Why would City 2 and 3 be pulling 19 and City 1 and 4 pulling 6? Oh. Okay. Yeah, sorry, I'm an idiot. I zigged when I should have zagged. And this is why I kept the windows up so you guys could see. Sell power from one border to the other. Dude, you could arbitrage power all day. Yeah, you could arbitrage power back and forth between two different connections. With a priority switch, you could absolutely do that. At how much of a rate, though? It would take forever to make any money. We could buy for 44 and sell for 47 cents. So 3 cents per megawatt hour. That's nothing. But it's passive, so... Yeah, we buy on the ruble, sell on that, and then you'd have to arbitrage something else, because buying at 50 cents a megawatt hour and then selling at 39 rubles a megawatt hour is no good. We gotta restart the test. Because all the water pumps filled up. We only have a finite window of testing to get like maximum power draw. Alright, let's try this again. Let's just double check. Apitomo is set to import. Right? Okay. Avriu is set to import maximum. Helios, import maximum. Rank up the power. Right? Now, let's get our switches up here. City 1. City 2. City 3. And shitty number 4. Sorry, couldn't help it. Okay, now bring up our input power switch. Input power. That's probably a better way to do this. Okay. So, let's just take this. Ready? And watch the switches. Okay, there we go. So with 3 of these things, we had enough power to get full wattage 2 things down. Well, not 2. No, never mind. It's the same result. Okay, cool. Now, with 3 power, with 3 of these, like we were doing a second ago, but we ran out of water tank. Set this, build this line. And now this is a connection that goes from my input power switch to 4. Let's see what this does. And go. Looping it equalized the power. See that? It equalized the power. Huh. Yeah, it equalized it. See that? We looped. Hey, EJ in chat. I see the RTX 570 Ti is coming out soon. Do you think it's worth getting? Do you need a better graphics card, Charles? That would be my question. The application is what is the point, the purpose of that, right? Yeah, looping the grid. And that's what I was wondering, dudes. A power loop could really help us here. What are we testing? Electrical logic in the game. Let me just make a new one. So we had input switch from 3 power sources, right? All at 18. And here's what this is doing. So we had one go out to a junction, right? That goes to a transformer, and the transformer goes to 6 substations. Right? We did this 4 times, so I'm going to abstract it a little bit, right? Right, this is all the same, so just pretend, 6 times right there. 6x, 6x. So, when we did this, when we did that, we had 18 megawatts at the input switch. Then we had 18 megawatts here. And then we had 9 megawatts there. Then we had 4.5 there, right? And then we had 2 point something or other, 2.25. Right? That was just a straight shot. Now, what I just did here was this. I added another connection and put that connection into number 4. That made every single one of these pull 9 instead. Interesting. Hey, Ting. Now, see, look, so that's my input switch right here. That's city number 1, city 2, city 3, and city 4. Each one of these is connected to a transformer with 6 outputs to all these water pumps. Why water pumps? Why did I use those? They draw power and they don't need any people. But we can only do it for a certain amount of time before they all fill up. Each one of these is designed to basically maximize out the substation. Draw the maximum amount of power that you can put through these things, right? That's the whole idea. And then I have 4 of them. We have city 1, city 2, city 1, city 2, city 3, and city 4, right? Detroit today, holy... Yep. Basically looks like my backyard. Yeah. Yeah, Baron. Yep. We should see what happens if we add another input somewhere on the loop. Yes. That's a good idea, Trey. We'd have to reconfigure the test again. But see, look, that doing that loop equalized our power, which is interesting. But our voltage is still down. Anything past the input switch is pulling 87,000 volts, not 109. Introduce a second input at City 4. Okay. I'm testing electrical logic today, guys. That's really what I'm trying to do. So now, here, let's put another input switch over here. All right, just put it right there. Put our big boy line into that second input switch. Second input switch to City 4. Input 2. Now, we got to find another electrical connection. There's one. We'll just start with one connection and we'll go from there. Yeah, see, we're having electricity problems because we are pulling the maximum amount of power through these things. And we're struggling, it's struggling to keep up. Now, the interesting thing here is that with the second input switch being in this loop, right? City 4, it's not equalized anymore. The power is not equalized. Interestingly enough. Now, what happens if we add another line in? What do we do then? Let's see. So, input 2 is hooked up. Okay. So, let's put this all in order again. Pause the game for a moment. This is why power stations have so many gauges, by the way. Okay. I'm gonna put the input switches here so we can see. All right, ready? Unpause. Did you set the new border? Yeah, Peg, I did it. Voltage is good across the board. Wattage is fluctuating, though. Is the wattage fluctuating? Go to the overlay. Is it fluctuating because these things are full? Nope. Nope, none of them are full. What is the observable takeaway? I'm not finished. Now cut the loop? Oh, okay. Yeah, that's a good idea. So City 1 and City 4. 1 and 4 are closest to power sources at this point, and it's halving it. Well, not, it's actually not halving it. It's taking away a quarter? Interesting. Does the game slosh power usage around each game loop? I don't know. Voltage is solved, but wattage is not. Okay, I got an idea. Take the line coming from Apatomo. Get rid of it. And run to there. So each input switch is now has 2 power plants going into it. Wattage could be fluctuating because you overloaded the substations. Yeah, Runar, yeah, that's true. Yeah, 12 to 9. That really didn't seem to have any effect. IMO, it's now over, then it was over. Jim Free is leaving NASA on Saturday per 2 people familiar with his plans. Yeah. Yeah, we're starting to see wattage drop because all of these are full. Interesting. Interesting. The looped power equalized it, which is weird to me. That's... I don't think so, Nova. Let's test again. That electrical guide on Steam has some good info. Might want to scroll through it real quick. All right. I was in the middle of something. Ultimate electrical guide. I don't own workers and resources, which property whoever owns it. I did make this guide though, so I appreciate being credited if anyone wants to use this in their work. Okay, Silent Shadow. The guide is up to date. I did not call this guide the complete guide to electricity because I don't know everything about the system. That said, don't take my guide as crapping over the developer's game. I think they've done an admirable job in making it the most realistic simulation of an electrical power grid of any game to date, while keeping the game fun. And that's coming from an electrician. If you're a new player, I recommend playing the tutorial for electricity if you haven't. It's already a good crash course in setting up a basic grid. Each building with electricity will have 2 electrical meters for voltage and power. And each meter has 2 portions, an analog gauge with a needle and a digital output below the gauge. Okay? The gauge portion will display the building's operating range from 0 to the building's maximum, and it will display the reading with the needle. The digital portion will display the exact... Okay, we know all this already. Voltage meters and voltage overlay in the game help give you an idea as to the state of the grid that the building is connected to. Keep in mind that these meters are displaying local information, so nodes further away may not be accurately represented. With the voltage reading at its maximum, it means the building is connected to a powered grid operating well within its limits. If the voltage falls a bit below maximum, 90 to 95, then the grid is nearing a limit in supplying energy to the meter's building. If voltage falls to less than 80% of its maximum, a limit is definitely being reached, and the game may start issuing power outage notices. We saw that. If the meter reads 0, and either building is not connected to the grid or the grid is severely overloaded. If voltage is oscillating severely, then the grid is unstable or possibly undergoing a power transient. Yep, okay. Power meters in the wattage overlay can be used to determine the output of power, the output of power producers, and the demand of power users, and are crucial for detecting ghost power discussed later. Keep in mind that for the voltage switches and transformers, this number denotes the net power leaving from or being consumed by the node or building, which may seem screwed up. Keep in mind, for the voltage switches and transformers, this number denotes the net power leaving from or being consumed by the node or building, which may seem screwed up sometimes due to the way the game simulates electricity. Power meters and the wattage overlay are useful for troubleshooting, mostly to see if a power line or node is at capacity or using more current than it should be getting. So, Jacobs, you're wondering the conclusions here. My conclusions here are how to distribute power correctly. Like, how many of these switches should I really put in line before we start seeing some problems? And that's going to denote my master design back on the main save. Does that make sense? Ghosts! Overlays are the best for viewing grids and troubleshooting purposes, yet more experienced players can use it to see the flow of energy, Matrix style. The game provides 2 overlays for electrical readings. Overlays will only display in megawatts and volts, but are more precise than the meters. Power will be displayed down to 1/10,000th of a megawatt, i.e. 10th of a kilowatt, while voltage is rounded up or down to kilovolts. The second more important function of these overlays is the ability to see the conditions of power lines and cables through the use of color highlighting. So he's talking about this. Right now, everything is green because there's no power going through these lines. Because, yeah, we reset. So, jump back. Voltage overlay, green denotes the line can transmit energy, no other colors are used. Wattage overlay, color denotes how close a line is to the power limit. Closer to dark green means far from the limit, while closer to dark red means it's at or over the limit. Both overlays. No color highlighting means the line doesn't connect to anything. Okay. You need to let the game run to highlight the lines. Note the uncolored and unconnected 1.5 megawatt line, the green unloaded 2.5 megawatt line, and the fully loaded 18. Be aware rebuilding cables can hide problems. There's also a third electrical overlay for building network connections under city planning overlays in the overlays menu. This overlay will display low voltage connection points for buildings and will highlight buildings that are connected to a low voltage source in green, while unconnected buildings have no overlay. Okay, tracking power is fine. This section explains the functions of the various electrical buildings included in the game. So, power plants. Power distribution nodes. These components are used to split, join, and convert power. They generally fall into three types: substation, switches, and transformers. There are mods that combine switches and transformers. There are mods that combine switches and transformers into a single building. Substation, used to convert medium to low voltage for buildings to distribute power. Buildings will automatically connect, provided they are within range. Yeah, we know that. Okay. Switches are used to split or join power of the same voltage, medium or high. The game has two vanilla switches, high voltage and a medium voltage, each with 3 connection points. You would use this for branching from a higher power line to smaller power lines to switch between power lines and cables, or to join up power sources into a single line. Okay. Maximum of 19 megawatts per node. Maximum of 22 nodes. Used to split or join. These are transformers. Used to split or join power of varying voltages. Or to convert power between high and medium voltages. The game has 1 transformer with 1 high voltage connections and 6 medium voltage connection points. Typically, this would be used to split a high voltage, high power line into several medium voltage, low power lines for final distribution. But it could also be used to collect an output of 6 windmills and convert it to a single high voltage line. You can also do a combination of the two, such as 4 windmills and a high voltage line feeding into 2 medium voltage lines that supply a city. Okay. Hey, Damians. Electric vehicle connections are fine. Hope you've been well. Yeah, I'm good, man. I'm good. I'm reading about electricity and workers here. There's a guide that Aqua found in chat. Let's see what we got. These are used to connect the power sources to nodes and some buildings like the aluminum plant. Each cable and power line has a limit of the amount of power that can pass through it, which may be a good or bad thing depending on what you need. Cables and power lines are further divided into high and medium voltages. Power lines are built above ground while cables are built below, usually, barring bugs, and have these main differences. Power lines are quicker to build, generally cheaper to buy than cables, but cables become cheaper if you only buy the materials needed for construction and then buy it with your own workers. And then build it with your own workers, due to the cost. Okay. Cables can travel across any length of water, while power lines are much more limited. Cables compete for less surface space, and you can build them deeper underground if you need. You can also cross the wires of power lines with no effects. Power lines have higher capacity caps, though this can be somewhat mitigated by splitting the power line into 2 lines and cables. See, Jacobs, here's where our grid differs from the rest of the world. Because of how our power system works, our power poles have smaller transformers. Those small transformers take medium voltage and convert them to low. Basically, doing that. We have one of these on almost every single power pole. Those are those cylinder things on the power lines. They're about this big. right? Maybe like the diameter of a basketball, right? That's a small step down transformer, taking medium to low voltage for your house. The game does not have that. And I found that really freaking annoying for when you're trying to make above ground power lines. The reason why is because you can't split. With our system over here, you could just split the line. It's not a big deal because the transformers are all along the line. So you can just split it. You can split it a lot. The pots, yeah, that's what they're called, Cake, exactly. Node limitations. Nodes cannot have more than 19 megawatts on average pass through them except for priority switches. If you feed two 18 megawatt lines into a high voltage switch and try to take two 18 megawatt lines out, you will only get 19 megawatts or so at most. The missing power will not be transmitted from nor generated at connected power sources. Priority switches are an exception to this and can have as much power flowing through them as you want. The rest of the world doesn't do that. I'm sure they do to an extent, Trey, but not like we do. All right, how does this work? All right, what happens? Oh, look. With the priority switch, it's directional. Oh, these work like a power regulator. Okay, EJ's learning. F to Jim Free. Yep. Well. Medium priority, high priority out. Okay. I want to see what the priority switch does in terms of power consumption. So, City 1. Do it again. City 2. Thank you, Aqua, for linking this guide. I'm learning. You tried Y-Walk? Now, because this can combine signal, let's see what happens. Yeah, see? Okay. Okay, this, yeah, alright, I see it. Is low voltage three-phase a thing? Yes. You can do that in the States, sure. You could have a regular outlet Jacobs three-phase at 120. And then you could have the big outlet, like the dryer outlet, 3-phase at 240. Fun fact, you could also have single phase 120 and single phase 240. Yeah, that's what I mean. We have two different types of plugs, right? Low voltage and higher voltage, right? And you can get those depending on how your circuit breakers are set up. You can get those in either single or 3, which is pretty cool. Yeah, Rin, I saw it. Mm-hmm. Okay, the priority switch is just equalizing where you can pull from in our experiment. That's fine. Power will not transmit through more than 22 nodes, or 19. However, if you make a substation, the 19th node, buildings can still pull low voltage power. The junctions and switch yards of power plants are not nodes. You cannot route power through power plants nor foreign connections. If you build a power line to a foreign connection set to cell and build another line from the foreign connection to supply an area, it will not transmit power nor voltage. Okay. Hey, username 47 monthly sub. Each cable and line can only this is cable and power limits. You can only transfer up to its rating. This can be useful for limiting the power going from a plant to an area, but it can also lead to a situation where an area has a brownout or even a blackout while the power plant is idling at a low power. And the reason why won't be evident. Be careful when routing a line with many branches coming off of it, like what we're seeing here. Using switches, you can split the capacity of a power line cable into two or more cables and lines and join them back up with another switch. These cables lines need not have the same power rating, but it looks better when you do. Interesting, man. The wattage overlay will show that one line will assume all the load until it's overlooked, and the other lines will assume the remainder of the power. There seems to be no downsides to overloading lines. In reality, if you overload a line, it catches on fire. Yeah. Or, you know, it could arc it. Well, electricity, if the line's overloaded, will find the path of least resistance, and sometimes that's a tree growing near the power lines, which is why you don't plant trees near power lines. Because, yeah, a lot of power going through it, it'll arc. If the line's overloaded, the path of least resistance can be through the air. Yeah, whoops. I know that. You can split the capacity of a power line cable into two or more cables lines and then join them back up with another switch. Cables lines will not have the same power rating, but it looks better when you do it. The wattage overlay will show that one line will assume all the load until it's overloaded, and the other will assume the remainder of the power. There seems to be no downsides to overloading lines. Oh, yeah, okay. Yeah, it fills one line up and then the excess goes to the other line. Got it. This is what I'm messing with now. Means power lines are not loaded equally. Unless you use a priority switch, it's not... Okay. You might do this because you need to switch cables to cross a longer stretch of water. And since cables have a low power rating than the large line does, you will need multiple cables for lines above 12. Dude, this game is tits. I love workers. Yeah, you gotta be, that's what, see, this is what I'm wondering. All right, this is the overall thing that I'm trying to figure out. How much room do I need to leave for these power lines? What constitutes a time where you would need to run 2 of them instead of 1, right? What's like your maximum load that you can put on one of these things? I'm learning. This is cool. You could split. You could have a big line going to a switch. The switch could split to 2 underground cables, right? And then you connect them back at a switch again, and then go to above ground again, and it'll work. That'll work correctly. You can basically do, because the underground cables don't have the same rating, you can go above ground, underground, split, right? And then above ground again if you're going over water or something. You could split it twice. That's cool. This is why I bury everything with 12 megawatt lines going everywhere. That is more expensive why walk, but yeah. Cool. Oh, I just thought of a much cleaner way to do this. To build my substations. Okay, hold up. So, every substation that I kind of build is just a regular switch going into a transformer. And I always thought it was stupid because you have to put one span of gigantic big power lines here, right? So, a better way to do this would be to pony up some extra cash, right? Build this, right? And then build your transformer. Oh, your transformer only has 1 input, though. Nah, never mind. I was gonna say put 2 underground lines going to the transformer, but it doesn't work like that. You need 2 inputs on the transformer for it to work correctly. So, yeah, substations are gonna have to stay with that stupid line just sticking up like that. I hate that. I hate it so much. But, what are you gonna do? You might also do this because you want to save money on construction. 2 high voltage switches, an 8 megawatt line and a 10 megawatt line, are priced at about 1/3 of the cost of an 18 megawatt line. And you could start off with the very affordable 8 megawatt line and build the 10 later when you need it. That's what see, that's the kind of stuff I'm talking about. Be aware, switches can burn down and that no power is transmitted when it's burning. This method introduces more weak points into your electrical system, so use it wisely. There are also significant issues with doing this in a grid with multiple sources, so avoid splitting cables if you're unfamiliar with the pathing system the game uses for load division. That's what I'm trying to figure out. The pathing system that the game uses for load division. Splitting power plant capacity. Because the switching junction yards of power plants are not nodes, and therefore cannot transfer power across themselves, you could simply connect multiple grids to the same power plant without connecting all the sources of one grid to all the sources of other grids. Power plants seem to prefer splitting their power equally among all the nodes they are differently connected to, up to power line cable wattage limits. Actual connection of multiple power sources will be discussed in the next few sections. Okay, foreign power overdraw. I understand that. Basic grid theory. Here's what I want. This section is for those who want to know exactly how a grid is powered up and loaded when blackouts and brownouts occur. Actual load division is discussed in the next section. If you are a new player, you might want to just skip this. I do not. Grid theory. This is my working theory on how the grid generally works. Feel free to correct me and bring proof. This game simulates electricity first by defining buildings with a voltage rating. Low voltage is 240, medium is 22,000. High voltage is 110,000. Okay. Medium voltage switches. Got it. Cool. Pause. When you connect buildings together, you have a grid with a capacity for equal energy to the sum of the grid's buildings' voltage ratings. The electrically minded amongst us might think of the game's grid as a bunch of capacitors wired in parallel. This is the energy storage the preamble references, and probably not what you thought of then. Sorry to disappoint you. Oops. When you load a save or start up a power source on an unpowered grid, energy will flow in this order. Yeah, James. Something like that, right? Power producers create energy and fill themselves up with energy to their maximum voltage. 110, high voltage, 22. Yeah, okay, cool. Next, every building and node in the grid except for substations, the buildings only they connect to, electric vehicle connections, and factories will simultaneously start accumulating energy and voltage up to 80% of whatever the highest voltage it can accept is. Then, nodes will start accumulating energy with a bias for the nodes further away from power sources, while loads, substations, electric vehicle connections, and factories will randomly get power. That's what we saw. I haven't discovered the pattern yet. I suspect it has to do with its power or voltage rating, and if other similar loads are located on the same branch with a longer string. Line capacities probably factor into the logic too. There seems to be a preference for the end of a string of nodes being filled first, with the shorter and closest strings being preferred. There seems to be a preference for the end of a string of nodes being filled first, with shorter and closer ones being filled first. Yeah. Wait, what? Being preferred to fill first. Okay. Hey, Vulcan, what's going on? That's why we're stuck at 88. Yeah. Every building and node in the grid except for substations, the buildings only they connect to, electric vehicle connections, and factories will simultaneously start accumulating energy volume up to 80% of whatever the highest voltage it can accept. Eventually, nodes and buildings all fill up to their maximum voltage and power. Eventually, nodes and buildings all fill up to their maximum voltages and power flow stops. The size of your grid and the power capacities of its power lines and cables will determine how quickly this process happens. Most simple grids will fill up in seconds at most, while some may take a minute or two. If all power sources are disconnected or turned off, the entire grid will quickly bleed energy off until none. Yep. Drawing power from a power supply proceeds in this order. When a load is connected, it fills up with energy to its voltage rating and starts deleting the energy in its building, which represent as a lowering voltage reading at the building. I think electric vehicles just transfer their power demand to the road and track network's power connections. Their road and track network is not simulated beyond that. The game will check voltages in adjacent nodes and attempt to equalize them at a rate limited by the sum of power ratings of the lines that can connect to them. If the power supply exceeds the demand, the voltage will become roughly steady. That is basically what we saw, huh? If power demands exceed supply, the energy in the building and its voltage reading will continue to decline until it reaches 80% of the building's rating, upon which the power draw will be throttled to whatever the grid can spare. This is the point you might see brownouts and power warnings issued. The method the game uses to decide what amount of power to throttle power demand down is unclear to me, but it seems to rely on these factors. Power rating, multiple buildings. Okay. This process is why heavily loaded buildings tend to stabilize at 80% of their maximum voltage, Rating 88, 110, 17.622 for medium. Before plummeting towards 0 when enough loading is added. I suspect that this is one of the potential causes for wattage readings of connected power plants swinging several megawatts of power every second or so. The power draw from the grid should be constant, but varying voltage levels may pull energy from other nodes and effectively unbalance the grid, causing the power plants to see a dip and a surge in voltage and thus ramp up or down generation to match it. Okay. Another big question is whether the nodes at 80% voltage have their energy refilled solely from connected nodes or sources, or if it refills it similarly to the startup sequence where it pulls energy directly from the power source until it's at 80. If so, this could also cause the wattage instability of a single power plant on a grid experiencing several megawatt swings every couple of seconds. That's why we saw the wattage going back and forth, because that. Yeah, exactly, Aqua. Grid theory main points. There are exceptions as discussed later, but generally, energy is stored and consumed in every electrified building. Energy is pulled to buildings from higher voltage nodes at a limited rate by the power line's rating. Loads will use up to 100% of their building's power rating until the voltage reaches 80. At 80% voltage, a building's power draw will be throttled down until the building surpasses 80% voltage again. The building's energy, and thus voltage, falls to 0 when its power demand is more than double the throttled power amount. Avoid having buildings in a grid below 90% voltage to promote stability. Okay, let me put that theory to the test. I'm separating City 2 and City 3's power lines. So City 1 and 2 are gonna go this way, and then there we go. It's incredibly satisfying watching those things get made this fast, because you know how long that actually takes in your realistic mode. They didn't hook anything up yet, bro. So City 1, 109 at 19. That's perfect, right? What about City 2? 88 out of 110. And you're halved. So if I saw this right, City 3. What the hell? Oh, game is paused. So, in this, everything is capped at 88, which tells me we're not feeding enough power. So, if we do this, now what? Does the voltage go? Not really, Flacken, no. That's very strange. Here, let's speed this up. I just want to see if this... Interesting. Interesting. Yeah, this is not... It's not adequate to keep those functioning. Crazy. Huh. Yeah, that wasn't enough. Huh. So our voltage is good. Oh, they all filled up. That's the reason. Okay. You think the priority switch is the bottleneck? All right. I have one more idea that I want to mess with, and I want to... We'll reload the test save. And then I want to... Yeah, I want to check this out. The common given rule of thumb is that loading of a grid is equally shared with each of its power sources. Well, power source priority is based on the number of nodes between the load and the grid's power sources, but that's not the case at all. What really happens is that the game will find paths from each load to all power sources on the grid, and from there it decides a behavior for each path. These behaviors will be discussed in greater detail in later sections, but for now you should know this about them. Node prioritization. Nodes with multiple, directly connected, no nodes in between power sources will prefer to load one of the sources before the others. Oh yeah, ghost power. Interesting, okay. Okay, there's something that I want to try. Let me modify the existing lines here. Get rid of that. Get rid of the lines that connect all these cities together. Okay, here's what I want to test. So, start with a line here. Right, over here. Put down a switch there. Put down a switch there. Put down a switch there. And put down a switch here. Now connect that to that. Connect that to that. This goes to that switch. This one goes to that switch. This is just more benefiting me at this point. I just want to see how this all kind of comes together. So right now I have a main line, right? And then along the way it distributes to each city. Does the number of nodes matter? Yeah. Okay. We've got power and connectors. And connect. All right, let's take a snapshot here. Man, that's weird. Yeah. I think this is because we're not getting enough power on the line. Here, let me move these up here. So this is the city switches down here, and these are their splits that's connected into my quote-unquote main line. Right, let's go here. Let's see how dumping this in works. The weird thing here is that this one, those ones are the same. Those ones aren't. Can someone explain the name of this game to me? Workers and Resources Soviet Republic is what it's called. That one is 98 though. What are you trying to figure out here? Just how power distribution works in this game, that's all. Interesting. So over here is this where power is coming from. This, so that right there. So this, I made a main line. These ones right here, these guys here are on the main line, right? And at each one of these switching points, right? Each one of these switching points, it switches to these are switches that are attached to a transformer. So the power comes in right behind my head. Power comes in right here, gets distributed that way, and every time you get to a node, it goes up, right? So this one goes to that one. Then power goes over here, goes to that one. Power goes over here, goes to that one, and then it goes to that one. I'm just checking what I'm doing today is making sure I understand how electricity works in this game, or at least have a good enough grasp on it. To make the electrical grid for Yakograd and make it not suck. Like, I gotta figure out where we should future-proof. How big do we want to make this thing? Right? Like... So, now what I want to check is I want to go here and cut off the last two cities. Right there. Now what does this do? That one filled up. And now this one should fill up. And now this one should fill up. And now the last one should fill up. I did LSRs, but my grid was about as coherent as a spider weaving a web on LSD. Yes, they tested that in the 50s. Good. So that works. The spider on THA didn't build a web, it built a hammock. All right, one last test. Or, well, not one last test, but I need to do another thing here. So we're screwing around with, obviously, we're screwing around with import connections, right? I don't want to do that. Let's figure something out here. Pipeline. Foreign pipeline connection. You have no idea how annoying it is that you can just place that. That took me forever to get one of those stupid things. Now, we need a oil power plant. That's a refinery, not a power plant, you idiot. Okay, so the oil power plant in this game outputs 1,050 megawatt hours of power. Okay, how many big connections do we have on? We only have 2. Tally. Gotta wait till the power plant gets built. I just want to mess with supplying our own power, you know, instead of using a foreign connection, because these can generate more power than foreign connections. Michael Sheets joined Firefly. Yeah, I know. Cool. Okay. Let's save. Yakograd test save. Overwrite the test save. Cool. Now we got an oil power plant. All right. So this is still with everything in series. So this is City 1. City 2. City 3. City 4. Each one of these, once again, each one of these things are connected to nodes of water pumps, and the water pumps are designed to basically max the power out, maximum draw, and they're all one after the other. So City 1 switch is connected to 2, connected to 3, connected to 4. Everybody got that? Cool. Excellent. Before we do that, I'm actually going to just save. Right here, we're connected to an input switch. Save one more time just so we have the names of everything. Cool. Right, so we have our input switch. 1, 2, pin the window, 3, pin the window, 4. There we go. Pininfarina. Cars. And then we have our oil power plant. We need to import crude oil. Hang on. We might need to jumpstart power. Hold on. You don't need a pump, it'll pull when there's workers. Got it. Alright, put the power plant there. Pull up the input switch. Alright, let's see what this does now. So we got power plant going to input switch, city 1, 2, 3, and 4. Alright. Now what happens if we cancel that? It doesn't make a difference. Okay. So yeah, we're seeing a drop between 1 and 2. It's halving the watts. Right? And per what the guy said, Silent Shadow, if these are at 88, that means it's not good. You don't want that. These need to read, the voltage needs to be at the max. So what we do is we take that wire from City 3, we get rid of it, and what happens if we do this? So obviously City 3 and 4 just went offline because I cut the power. Now they should turn back on. Ooh. Power plant shut off. Jeez. Wow. See, I look at something like this, and now I'm like, oh, balls. How undervolted was my entire network on Bakalaka? Now I'm really wondering, because I only had 2 power plants on that entire map. Wow. I can't believe I didn't have more power problems, dudes, to be 100% honest with you. How the heck was one gas power plant powering all of Aribi and all of, what the hell is the name of the center city? Oh, Al Supenladel. My center city at Bakalaka and one of the cities by the borders. I had 1 power plant powering that whole thing. I should have had like 4. Most things don't pull 100% all the time. 2 power plants is enough for maybe 100,000 population. Are you sure Wednesday? I mean, but then again, I do have... Every one of these is connected to a node of water pumping stations that are designed to maximize out the grid. Like, this is worst case scenario stuff. Worst case scenario stuff, one power plant can barely run 2 of these things. Like, barely. These nodes are designed to maximize the amount of power a transformer is using. Aren't you still importing? I don't remember. The nuclear puts out 4 gigawatts of power, which is actually pretty crappy for a nuclear power plant. That's pretty low. That's the single, though. What about the twin? The twin puts out 10 gigawatts. That's... Yeah, that's more or less in line. Hey, look, it's filling up City 2. This will eventually get to 109. What about the Ukrainian power plant? That's the Zaporozhye 58. Wow. How much does that coal power plant produce? Coal is 1,400? It's more than the gas power plant? Huh. There we go. Let me just see what this is. Yeah, that's working. Yeah, guys, it's basically just keeping, you got to keep your voltage high. Keep the voltage high. Yeah, okay. I mean, like I said, these are power leeches. The nodes that I've made here, they're power leeches on purpose. Like, that is absolutely supposed to be like that. It's really supposed to break things. Like, I'm testing for worst case scenario. Because I was thinking you could put 2 of the medium-sized new power pad down to get more power. And Yakograd, I'm testing, Dean. I've done a lot of testing today. You're constantly adding wind power as quick fixes and burning up transformers. Yep. Max medium is 2.35. Okay, one more test, just with City 1 and City 2. I'm going to see if sending power to these in parallel instead of series is better. So, I have my power plant out, split to one and to the other. They're basically equidistant nodes of separation here from the power plant with this test. Okay, there she goes. It split the wattage perfectly. We're losing power drastically with efficiency here. Yeah, the priority switches are really good. Yeah, that makes it so you can really kind of control where your power plants are, like where your power's they're coming from. Once again, keep in mind the nodes, the city nodes are maximum power draw. I'm really seeing what the upper end of this thing can do. And this is a lot. Each substation has an array of 30 water pumps, dudes. So this is... I'm really putting the system to the test here. I just want to see what it does. Gibby, I love seeing you play this game. I played a long time. How do you play game making me think of new ways to play, not the same as you. Yeah. There we go. It's saturating. Good. Good, 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 good. Just like the dude said in the tutorial, these should go up to 109. Yep. Oh yeah, baby. Look at that. That's stable. That's working. Yeah, splitting this up. Splitting it up is the right move. Okay. Oh yeah, yum food? Nice. cool. I can't find it. All right. Okay. So distributing in parallel like this is an interesting way to do it. One last thing that I want to do here is take this and loop it. So this is it working in a loop now. Just curious to see what happens here. Boom! Boom! There you go. Look at that. Oh, it was at max power for a second. No, no, no. No, go back up. Duh. What is this? A spin prop? What are you making that thing do, Yum Food? It looped. I had it looped for a second and then all the water wells filled up, so. What happens if you introduce one extra into the middle of the loop furthest from the inputs? Did they all end up with the same? Or do the outer two have the same and the other one have less? I don't know. This gets complicated really quickly, dude. The other benefits of the loop is redundancy. Loops seem to solve these problems of like distributing power evenly. They really seem to solve it, interestingly enough. And I'm not sure why. Let me just confirm it one more time, just to be absolutely sure. So, if we did this right, both of those gauges should max out when the power plant turns on. It's just dependent on the bus. Okay. Okay. Now let me draw this. So, how I have this set up, you down with OPP? You have the oil power plant. Hold on, let me just draw that better. And then I have a line going out to a switch, right? That one's going to another one over here, right? This is C1, and that's C2. And then I have a junction line that connects them like that. This distributed power evenly between C1 and C2. Maximum wattage, which is weird. Hey Exo, what's up? Looks as simple as hub and spoke. Spoke with the highest draw is your limitation on how many spokes you can have.
Discovery, go at throttle up.
And then, obviously, these led to a transformer, right? Each one of these leads to a transformer, right? And then the transformer distributes. Now, what I'm really wondering here okay. There's a lot of ways to do this, dudes. There's a lot of ways to run this. Like a lot of ways to run this. Okay. Okay. Aqua, that loop connection, that L, or the backwards L, this thing right here, when the power plant was running, this was 109 kV, right? And then this one, City 1, was the exact same. This may be unneeded, but what happens if you have another oil power plant powering another 2 cities that also loop into this network? Frango, that's where I was going to go with this, dude. I'm not sure. Is there voltage drop over power line length in this game? I don't think so, Snoopy. It doesn't seem like it, but I haven't really tested it to more than a couple of miles. I have a good way to test that. That was really the last thing I wanted to test, but... So, Frango, how would we loop this? That's the real question. How do you loop? So, okay, so City 3 and 4 are already connected, right? And then we have a switch here like that for them, right? And then connect into 3, connect into 4, right? That's making a loop. Now send this back this way. And how do we loop this? How do you loop this connection? Right, do we use a bigger switch? Let's try that. One big connection. No. So I have one big switch from the power plant going into a loop between city 1 and 2, and then going down here into another loop between city 3 and 4. It is distributing power evenly, guys. That distributes more or less evenly. We are not generating enough power in this scenario. That's the problem here. Yeah, we're not generating enough power. So, just out of curiosity, what happens if we do generate more power? Just build a bunch of RBMKs. What could go wrong? Look, that's pretty damn even power distribution, interestingly enough. What if we add more power? More power. More power, Mr. Sulu. Oh, man. Not a good test because all the pumps saturated. Need more feeds into the loop. I think that was the problem there. But tech, we were distributing power evenly. That's what I'm after. Distributing power evenly seems to be the right move. And if we just go look at this the wiki page on power grids, and I noticed something. This is the reason why I wanted to try this. Look, the grid around all your big power plants loops. Now, I'm not sure if it loops. I'm not sure if the reason why this works in game is the reason why power grids are looped. But also, just saying. The other thing is that, you know, the other system that we could do, guys, for the main city is just, okay, say this is your border power, right? You run it, switch it every once in a while, right? And then let's say, like, every, I don't know, like third switch, put a power plant in here, like an oil power plant, right? And go. that should evenly distribute power, like a hierarchically. Okay. Let me just read the pathing part. I'm interested. The pathing system. I highly doubt this game does the method exactly and deliberately pauses ghost power, but the results appear the same. So the method below can be used to predict the behavior of your grid designs. When a load is connected to the power grid, the game will look for all the nodes in a grid that are directly connected to sources and compile a list of paths between these nodes. Paths with over 19 nodes are ignored. Okay, so 19 would be our limit. The path with the fewest number of nodes in it becomes the baseline for comparison. For brevity, this path will be referred to as the base path. The base path gets one share of the load, of the loading. Game will determine each path's behavior by looking at the extra number of nodes in it. It's completed the base path. If the difference in nodes is 0, the path will get one share of the load. Ghost power may occur, but the potential for it is very low, possibly even non-existent. 1. Then the path will get one share, but it is a very high potential for ghost power. 2 or more, then the path will not receive a share of the load unless a ghost gate will occur. Loading is then split equally amongst the paths with a share. Since most loads and sources on a grid are connected by the same power lines and cables, you will see higher wattage where the paths overlap. Dinner is done, okay. Workers is on sale in the Epic's Game Store, 50% off, by the way. Cool. Yep. This is what I wanted to see. Here it is. Yep, okay. The third and final limitation is that since all power sources need to be connected to the same node, the number of sources they can directly handle by a node is limited to the number of connection points it has. It's especially a problem for windmills because they have a low power to connection point, and thus a lot of them need to be connected to have a decent summed power rating. But there are 2 ways to make that work. Mods help a lot. There are some recommended. Yeah. You can make wind farms. You can make wind farms in this game and then just export the power. Yeah. You can make wind farms to feed into your grid. You plug the wind farms into a transformer, and the transformer will step up the power generated and backfeed it into the system like a power plant would. So you could basically, wind farm, you can make your own power plants. It would be super cool if they did that game mechanic with solar panels. Like, so you could make a huge solar farm. That would be awesome, instead of just placing down one solar array. Yeah, that's node prioritization, ghost power. Okay. Yep, okay. Each load on a grid compares the path from itself to the nodes connected directly to one or more power sources. The path with the fewest nodes are each assigned an equal share of the load. While paths with an extra node get a share of that load, as well as the potential for ghost power. And finally, paths with two or more extra nodes will not be assigned any loading at all. I think ghost power is why the loop balances, I think. I'm pretty sure, yeah. There's a potential for it as denoted by the pathing system. The path has a comparatively low power supply compared to the source of other paths. It overlaps with possible causes include low generation capacity, low wattage, overloaded split power source. Give a large source more nodes to directly connect to so that it has more load shares to supply than other sources, i.e. a power plant with 5 nodes on a grid will have 5 shares, while another source with only 1 node will have 1 share. If no other viable paths exist for the load, the power plant would carry 5/6 of the load, providing no limit interference. For wind power, you would do the opposite. Have a main power plant directly connected to only 1 node on the grid, while there are many other nodes that directly connect into windmills. This way, the power plant would supply a tiny fraction of the load unless the wind stills and the windmill's outputs dropped. Wow, dude, this is great. Redundant grids with export. Yeah, there's your freaking power loop. Okay, so he confirmed it too. Yeah, the loops, but he's looping it to another power plant. You see that? That's almost the exact connection that I drew in Paint a second ago. Is Starship on for tomorrow? Starship? Where'd you get that idea, Matt? I saw a road closure. It might be just for moving Starship around. It's probably for moving something, not for a launch. There's nothing on the pad right now. Whoa. Yep. Yeah, you can get your SPPs to offset your power plants. Yeah, that's cool. I like that. That's really neat. Dude, that's crazy how nuts you can actually get with this thing. Okay. I think I've tested enough. He has a train guide. Yeah. I don't entirely understand all of what that dude said. I'm probably gonna read it on break. But anyway, we're back to Yakograd for at least a little bit. So I started setting up electrical here. Right? And how this is set up is that what I was doing is I have two nodes, Fermilios and Avriu, connected into a switch. That's what I started doing. And that's pretty much good for what we're trying to do. If we want my main power grid to go this way. Have you planned out your city? I have some of the roadmap figured out, Drummer, if that's what you're asking. What do you think? Anyone got a link for that guide? Yeah, I got you. So, Drummer, we have main distribution over here. And then the city's going to go over here. What I wanted to do is start working on utilities today, but the way the power works in this game is by far and away the most complicated out of any city builder. I mean, surprise, surprise. Okay. Alright. Guys, I gotta go take a leak real quick. What I think we should do is start looking at substation distances to make sure we get blanket coverage. Somebody suggested designing the grid backwards to get a good scope of what we need to power, right? And I think that's actually a pretty good idea. So what I'll do is I'll start designing the cities, and then we'll design the utilities around the cities. I just got to take a leak real quick. I'll be right back. Okay. All right, I'm back. Waste tanks were evacuated. Remo has hinted multiple times that you should go grab your food while it's hot. Okay. Yep. I'm gonna get back to building this. Okay, so. Did you see Jim Free is leaving NASA? Yeah. That's baseball diamond? All right. Sorry, I was thinking about something else. Okay, so we want to design the city. Would probably be a good way to just start messing with this. So let's place down a substation, right? And then we'll place down something that needs an electrical connection. 800 feet. Oh, it's a box. The AOE of one of these substations is boxed. Interdasting. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 17, 18, 19, 20, 21, 22, 23, 24, 25. Interesting. Okay. So how about we put substations 800 feet apart from each other? That'll give me an overlap of substations. So, right? You'll have one is this box, right? And then you could have another one, right? And then you have another one. Right? That way, no substation really would ever get overloaded. Are the roundabout single or multi-lane? They're 2-lane right now. Oh my god, rockets. I know that might not necessarily be the right way to do it, but, you know. All right. They look really good. Thanks, man. They did come out quite nice. Okay, so cool. Move dirt streamer. Yeah, right. I was thinking, and this is the reason why I flattened this kind of, you know, triangle akin area first. This is where I want people to, like, this is where the old town of the city is. Because, okay, look. I can only get certain types of structures here. You know. These are the ones that I like making. These flats. They're a medium flat. They hold about 110 workers. Not bad. Not bad for what they are, you know? Every time I look at this game, I get amazed at how complex you can get. It's really an amazing game, dude. Hang on, my space heater turned off. Here we go. All right, cool. So, let me think. I need to figure out walking distances between stuff as well. I believe the maximum walking distance on paved paths, I think we determined it's like 1,800 feet. I think. Let's check. Let's just plop a cinema down over here. And then just plop a little residency down over here. Now, footpaths, right? We connect it with a dirt footpath, right? Nothing. You can view the buildings that'll be reached on foot, and it's nothing. Because the walking speed on a paved footpath is better. Right? Can they make it now? Nope. Nope. Okay. Now what about this? What about a path with lights? Can they make it then? No. Alright, so how far are these apart? Okay, so let's go 1,000 feet apart here. Dirt footpath? No. Nothing. Okay. Paved footpath? There we go. 990 feet. Alright. We figure 1,000. 1,000 feet for walking distance. That's probably the best. Walking distance is 480 max. But at max walking speed, so I'm guessing the best path type, that's half with each path. Yeah, exactly, Bob. 95% walking speed there, and the just regular paved paths with no streetlights are significantly easier to make. But you said 480 max. Interesting. Okay. 480 is like 1,300 feet. So let's measure 1,400, right? And I'm just going to put another flat over here. Oh, no, no. Nope, not street lights. Paved path. It's very interesting that that worked that way. Okay, so how about we 154 this, guys? So what I mean is that about 1,540, actually, if the walking distance is 480, it's about 1,500 feet, right? If we, now how big is our, how wide is this at its widest? 2,300. It's 1,500. Okay. Okay, let's... So, what's a building that everybody needs? Building that everyone needs is the supermarket, right? We need a supermarket. Now, do we build the biggest supermarket first? Should we? I don't know. What do you think? We could start off with smaller ones. We could have distributed resources, smaller supermarkets. Probably would be cheaper. Right? We have a grocery store, right? And then we have, let's take a look. Let's take a look at all the different ones. My gut's telling me placing this right here would probably be a good idea. Placing the shopping center right there. Probably smart. But that's a big shopping center. And that does take time. 84 tons of steel, 423 tons of concrete. Now, what we could do... Well, this is going to be a big place, dude. I'm trying to think about where we would want, like, do we go with distributed supermarkets? Maybe we put a supermarket over here. Maybe we put one there. Maybe we put 3 of them, right? So we never have to worry about it. And if we all triangulate them within a certain distance, right? I don't think we need to worry about, like, oh, if this supermarket's out, I could just go to another one, right? Like, that seems right. Small shopping center C would be good for 25 people, 2,500 people. You have it in your save. So there's small store, big shopping center. There's the Okian supermarket. Oh, that's kind of neat. But that only has 1 warehouse connection. I don't want that. But then again, how much food can that hold? 15. Small shopping center C adds you as that one. Yeah? Okay. 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 Alright, let's start designing more roads. I thought I heard you say the mantra was no curves. Pertaining to what? No curve, why? I'm confused. The Workers soundtrack haunts your dreams. Me too. Roads the other day, it popped in your head. That is on highways, Salty. Highways. Yeah, highways you don't want a lot of curves. These roads are going to be relatively low traffic. In fact, it's mostly going to be for walking. Yeah, that really only pertains to highways, dude. Oh, I made that road too fast. Okay, proof that I'm semi-listening. Yeah, guys, I too hear the Workers soundtrack in my sleep. Okay. Now. Yeah, that one's better. That one's better? You know what? This looks too much like a residential design, not a planned city. I got another idea. Have you figured out what buildings you want in these spaces? I'm working on it right now, dude. Okay. Just a side tip for me, save your game in the cloud. As a player who's played the game 1,300 hours, I thought it was unnecessary, but your hard disk crashed. Okay. I just used the roads to get the spacing right, dudes. Now what we can do... Pull that. Pull that. And pull that. Much more subshit. Very nice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, let me measure how far that was away from here. 600 feet from center. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got a better solution. We'll just get our measuring tool out again. Measure the throw on that road from center to center. 554. It really doesn't want to make a curved road coming out of here. I wonder what happens if we do that. Can we... Good enough. And then right here, dump that. Something about this doesn't look right. Okay. I got another idea. At least I think. I don't know. Okay, let's try this. Split that down the center. Right? And then we need to get our profile again. There we go. Now we're talking. Now we're talking. Are we though? Hold on. No, that's not what I want. Stupid spooty spook game. Good enough. Next launch is on Friday, Gaw. that crooked? Stop it. That's too close to the roundabout. No good. We're gonna have to come up with something more creative in here. Because I like this. This is fine. There we go. Better to make the dang curves first. Nice. Now that looks right. Now this we can work with. Perfect. Good. Good. And once again, these will dead end here. And then we could just put a footpath or something there. It's a little bit this way. Probably should have put it one grid spot higher, but it's fine. Okay, so now... Okay, how are we gonna figure this out? We need substations, we need water. Trey, you've been very bored recently. I feel like nothing is happening in the spaceflight area, and games are filling that void. Games aren't filling that void either. I don't know what to do. We're in a holding pattern, man. It sucks. I don't know if you noticed, like with Space News lately, Trey, I've been kind of just totally cool with talking about like other things, like planes or whatever. Yeah, it's because the cycle is slow. We're in a holding pattern until we figure out what's going on. You know what? I changed my mind one more time. Hey, Mill. All right, so go to there, bring that down in there. There we go. That's much more planned city Soviet architecture. Excellent. Yeah, this is good. I like this. Much nicer. What do you guys think? That's a pretty good roadmap. I'm kind of worried, like I'm making sure that my interchanges aren't near anything, like the roundabouts aren't near the intersections. Trying to keep everything kind of spaced apart. So traffic can flow through the roundabouts and then it'll get distributed to wherever it needs to go. My roads are all super crooked. I was thinking another main-ish boulevard going through here would be a good idea, but I might have just screwed up all my damn curves. We'll see. 'Cause I need this thing to go. There we go. Now we can build the center there. And then we just gotta connect it in over here. Nope, I don't want that. No. Code didn't connect. Alright, so set that like that. And then what we can do to get this thing to really work is set us on that grid spot right there. With the curve, that's why we weren't snapped to grid. Now connect. Oh, why are you doing this? Whatever. Fine. Jeez. I'm gonna scream at these damn dirt roads. You have no idea, man. Well, if they're pissing me off. There's a certain rhyme and reason on how to make this stuff, and I have no idea what that is. Just kind of gotta hope that those roads came in right. There we go. If you force on a node if you force a node on a section before you connect it, it will come in correctly. Most of these are good enough, see Kraken, but yeah. What do you mean force a node? Felt like we were going very fast and everything was happening, then all of a sudden nothing. Hopefully it picks up in a few days or weeks. Yeah, Trey, like, yeah, no, don't worry about it, dude. They'll be alright. Yeah, B-Pad, it came in real good. Okay. Cool. Now, curve looked really hinky. That curve does not look good. It looks awful, actually. Like, wow, that was pretty bad. How about if we make it this way? Alright, hold on. Let me take off snap here. And have the curve end. Yeah, that'll work. Now just, yeah, once again, put a little turnaround at the end, and we'll dead end that road right there. ABL Space is officially dead. New company in its place called Longwall. Interesting. You know what? I like it better if that road just goes straight. All right, guys. So here's my plan. You guys tell me if it sucks or not. I mean, or you could just say it sucks. Like, it's fine. I want to put the clothing factory right here. Actually, that's really, now that I'm really thinking, well, clothing factory would be good right there. The clothing factory does not pollute very much. It's very, very low. Or we could just put more flats there and put the clothing factory on the other side. Put it over here. So that people can jump over here. Put a bus station. Well, we have a bus station. Let me just test something. No. Last. If you force to know, draw a road where you want it to connect, then the rest length and draw a road where you want it to connect, then the rest length, and then connect another node there, and boom, right where you want it. Okay. Yeah. Does that make any sense? Kind of, but I gotta get going for. I'm gonna go eat dinner. So we learned a ton about electrical today, guys, and yeah, we learned a ton about electrical, and we started road mapping this. So now from here, now that I got a good road map, we can start placing buildings, right? And then we could start placing our electrical, right? Wasn't dinner like over an hour ago? I mean, Yeah, it was ready over an hour ago. Pexter, I don't think you saw me eat it, did you? I don't think I ate it. Did I eat it? No, but why wait an hour is what I meant. Citroen, am I going to watch Four Nations tonight? Probably not. I'll probably be here working. You waited. Carry on with the workers. Well, Pegster, because I want to take a break right before space news. If I'd gone and eaten dinner when... If I'd got... Okay, a little bit about my schedule. If I'd gone and eaten dinner when it was ready, I would have gone, eaten it, been gone for 20 minutes, came back for 20 minutes, played workers for a little bit, and then took a break for space news. You know? EJ's addicted to this workers video game. No, EJ likes playing this workers video game. It's fun and enjoyable, and it's challenging. So, I was going to do Timberborn for After Hours tonight, but what I think we'll do is finish up what we were doing in workers, try to get that electrical grid diagrammed out, try to get plumbing and sewage, and then we'll play Timberborn tomorrow. Yes, he's totally addicted. Man, I don't have to take this. I don't have to take this crap. If I'm addicted, why am I stopping for space news? Riddle me that. But you know, chat, you've been real out of line. I might have to punish you by playing workers again tomorrow and the day after that to prove to you that I'm not addicted to it. That's something a deprived addict would say. No. Y'all got any more of that grading? Alex is like, works for me. No, please. I mean, if please, no, wait. All right. We'll I'll be back in a little bit. Probably about 20 minutes. And then we'll go. YouTube, guys, I'm going to jog the VOD. We'll start space news. And why are we stopping for space news? Because Jacobs is right. I like space more than I like workers. He's not wrong. Anyway, I'll be back momentarily. Going to take probably 10, 20 minutes. We'll get space news going, do some space news, and then jump back into workers. I'll give you guys another nice long stream today. Space news workers DLC. Yeah. Okay. YouTube, stand by for loss of signal as expected. Twitch, just sit here and enjoy the EJ tune, the Edge tunes. I'll be back momentarily. Thank you for watching part 8 of the Yakograd Republic. Like, comment, and subscribe, and hit the bell or something. I don't care, whatever. All right, I'll be back in a second.